Okay, I'll just go ahead and get started here. I have my ZTPFGI and I've already connected to a system, which you can see if I click there it says disconnect. And I'm going to quickly show the assembly program first. From my project view, I can load a program. That's part of the source view tracing, is to be able to lock it in. And you can actually load it directly from any of the sources, which would check and verify that the compile may need to be done and redo it. Or if you already got your SO built, you can just right-click directly on the SO. And that's what I'm choosing to do here. I'm going to go ahead and say load. At this point, we're sending that over to the vPars, and we're asking exactly which vPars you want to go to, because I was connected to this system. That is what's shown. And then on the source view options are down here, or along this line here, and down here. Automatic activation means it will automatically load it for you. And selective load means only I'll be using it. Some systems may not be able to load to the actual vPars based upon configurations, and they just don't want you to load programs. You can still source view trace on those systems, but you won't be able to load. You'll have to do it only on systems or programs already loaded. So I'm going to go ahead and check both those and select. So at this point, it's transferred the SO over to the system. It's loading it into the system and activating it. And then you get a list of what you want to source view trace. In this case, this SO just has one assembly program in it. And I'm going to say OK. At that point, we're locked into source trace. That means that when we do entries, it's going to stop on this program if it happens to enter this program. This little lock here identifies that, ready for source view trace, and also the icon up here is just a little different. If I say remove from source view trace, you'll see the icon has changed now. It's no longer locked, and of course over here the lock isn't there. But the purpose here is to be able to trace it. So I'm going to go ahead and do it. When it locks in, you'll see blue dots on all the lines that are executable and having assembly instructions for those. To test today, I'm just doing create ECB. It may be that you use an asynchronous trace feature to be able to capture the program, or from one of our couple terminals we have. So for assembly, we have the source level trace here. There's another option, which I'm just going to show you where the option is, but not actually do it. It's down here in trace behavior, source view trace. And you can, for assembly, you can say trace assembler using the listing, which you'll see the source and the listing kind of combined and has the displacements on there. Also on here is this option to not scroll left as we step through some files, or maybe the window itself was made kind of small and you may be the type of person who wants to scroll to the right a little bit, and as you step you don't want us to automatically scroll back to the left. And this option, we're going to show SaberTalk today. A couple companies do use it. So for SaberTalk, there's also these options if they want to trace with the SaberTalk source, using the assembly generated from the SaberTalk compiler, or use the listing coming from this. From there. I'm going to cancel that out. All right, we're still stopped in our trace. And you can see that I have an active ECB up here. And in our trace options, we have first is the run button. The run button, if I clicked it first, well, we're stopped right here on this line. That's what the bright orange, pink, means. If I hit run, it means to execute again until we hit a breakpoint. Now to set breakpoints, you go over here and you click on that and a breakpoint is set. Notice the blue background. You do it again, it goes off. So I go there and I say run. It will execute the XZ and the globe Z. The instruction hasn't been executed yet, and stop on branch and save before it executes it. As you see, we did that. Also, when we logged in, you'll see for assembly, the first thing is all of the register values are displayed in the local variable window. And in addition, any type of tags that within the assembly within a certain area, those are also shown here. So these are actual tags within the assembly macro that was coded. When I did that step, you'll see two things that changed. One is the contents pointed to by R4 has changed. That would mean, so not the contents, but the actual address register 4 had gotten changed. That's caused globe Z updated R4 to point to the global area. And also the EBW area got changed because we cleared out EBW 00. Along with the registers, I also want to point out this is saying that register 9 is based off of the ECB. So there's a quick little view here if you wanted to see if a certain DSEC has a currently using for a register. You can see it visually here in the window. A couple of small features in here. Let's say the EBW, for instance. I can change to display that as decimal. So now this field is being displayed as a decimal field instead of hexadecimal. I can switch back. In the EBW field, I can go and right-click and do a find, for instance, and maybe within that structure I want to see where EBW00 is. So I use find, and it went into the find of the local variables and found the EBWs off of R9, and it found you to that tag. So if you have a big structure like the ECB and you want to find a very specific tag in there, you can use the find feature in there to find it. If you want this to all get smaller again, you can collapse it. So now the ECB isn't expanded with the pluses and stuff. All right, back to our trace features. Let's say I want to go back to the top of the program right now. I can set my cursor there and choose branch to cursor. So the execution point will stop back to the glob Z at this point. As you notice, the pink changed. Now, no values actually changed to the registers or anything. So you do have to know what you're kind of doing here. If there's a certain register where you want to branch to, like here was a couple of load addresses, if I'd branched to my CLC, those registers would never have been loaded, and that probably would cause my program not to work correctly. But branching backwards is usually fairly safe. Run to cursor is where you can set a cursor anywhere into the side of the program on an executable program. If I set there, and I didn't test this earlier, we'll see if it works. And I say run to cursor, it'll stop where my cursor was at. Again, I'm going to use my branch to cursor there. These three features here, step into, step through, and step out. This is how you would know. These are the features you normally do. These two, step into and step through, when you want to trace. If you're not on an assembly, a branch and save, or call to another program, these two work exactly the same. If I say step into, it's going to go to the next instruction. If I say step through, it's going to go to the next instruction. The difference is when you're calling another function, meaning a subroutine assembly like a branch and save, or actually an enter to a program. At this point, if I say step through, it's going to execute that branch and save and come back to the next instruction. So right there, this branch and save was executed, but stopped next instruction because I wanted to step through the call. I didn't actually want to trace it. If I'm going to go ahead and branch the cursor back to the branch and save, but let's say I do want to trace it. So I'm going to do a step into. When I do a step into, now it called the branch and save and actually is letting me step. And again, at this point, now these are branch and save, so I can click, click, click. When you're in a subroutine or any time, you can use the step out also. It will execute rest of that function, and it'll stop at the next instruction of the calling. All right. Also, the variables within the inside the assembly program itself, you can take your cursor and just let it there on top of something, and you get a quick value. Register 3 is not initialized yet, so that's why the error address 0 is not valid to look at. If I look at R15, that is actually pointing to my program because you just did a branch and save, EBW, and so on. If there's something I really care about and I want to watch all the time, like EBW, I can right-click and I can say add it to my watch window. So watch window is things that you specifically pick, and it's going to show you the values of those as you step through. So I'm going to just step through a couple times here, showing different values as they change. See R15 changing, getting core. Now at any time when I'm tracing through here, I can go and I can actually look at more information about the actual instruction by clicking this magnifying machine instruction. And I click on that, and I'm going to go ahead and close this. We don't really need it right now. And so down here it shows that I'm doing a load instruction, but it tells me a little more about it. It tells me that it's R1 and R0 off R9 and what the actual data is at that point. So I'm seeing more information about this instruction. Besides seeing more information, the magnifying glass indicates to step at the instruction level now, meaning literally assembly instruction, not the source instruction. To kind of show this, I'm going to go back to the get core, which is a service call. May not be the best example. Let me try the globe Z. It may be the same thing. Branch to cursor. Okay, globe Z. Now when I step into, it still goes through. We'll show this more in assembly. Normally for assembly, for C. Mainly for assembly, each instruction is only one instruction. So when you go the magnifying glass, it's going to step to the next line. The exception is certain macros. If you have a macro that's 2 or more instructions, as you step, it will stay here on the macro, but as you step, it's going to change the instructions down here. So that's machine instruction. And go ahead and turn that off. So in a nutshell, that is most of the assembly type features. You got the variables, the registers, and the usings off of that. And then you have the tags. Let me expand that back up. And the different tags and their values that you can see as they change, and then the hovering. Is there any specific questions on assembly source view trace? We'll go into C, which is a little more information on that. Okay, if not, I'll move on. I'm going to go ahead and just say exit all my ECBs. And back on my load set here, I can just leave that. As you see, I can set the breakpoint even not being currently being traced in an ECB. So I'm going to, this time I'll load it from a source. I'm going to load this C program. So I say load on the make file, it's going to call make TPF and verify that if there's anything that needs to be recompiled. In this case down here, you see nothing was done for the build. That means I've already recompiled and didn't make any changes. The exact same source view screen you saw before, where to load it and how you want to do it. I'm going to say OK and say selective. It loaded it to the system and it brings it up, and this happened to be the last thing I selected. This C program happens to have 1, 2, 3, 4, 5. This is a compiler thing, but there's 5 different members. I'm going to choose the first one, say OK. So now you see the list of them, and you see this one is locked in, and also you'll see that here. Just like with assembly, you'll see that the breakpoints are automatically added on lines that are set up to be traced. I'm going to create an ECB to be able to test this. Okay, so I stop on the first instruction. We still have the similar buttons up here. And now instead of registers and a few tags, we have actual local variables. These are all the variables that are declared within the current function, which happens to be AP4. So at this point, I have a structure called regs, where it looks like I was just playing around with the p-test, and you can see the different values. I didn't show this in assembly, but you can at any time come in and alter the value. So now I altered it to be 0. It was uninitialized before. EBW doesn't show up as anything because it, of course, was assembly watch variable, and EBW don't exist in here. Now in this program up above, you'll find that I have some global C variables. Global mean they're declared outside of a function. In all honesty, being a C programmer, this isn't a good practice to do this. It's kind of, you have to be sure you clear them when you leave and all that good fun stuff or reinitialize. But if you happen to have a program that has global C variables, you will not see them down here in the locals. This is the current function you're on. So to be able to see up there, you can right-click and say Add to Watch and see what that value is. So if you got global C variables, one way is to hover, and you'll be able to see it, or to add it to the watch if you want to trace and watch where it goes. Just like before, run will run to the point of a breakpoint. So if I say run, it executes all the way up to that point. If I want to go back, I can set my cursor, branch to cursor. All right. Now, for source tracing, if I say branch step into, this actually is a constructor for an object in C++, and there is code to execute. But I have not locked in the C++. I'm going to change a view here real quick, if I can find it. View load list, where is that? Variables, trace options. Sorry, something I normally have up here is not right this minute. Can't find it right now what I was going to do. But you'll see if I say step into here, it just executes it. That's because it's not locked in. The only program I got locked in is this one source, and that data was not there. Now I'm going to branch to cursor. Now we have this other option called source mode. Source mode says that I want to come here, source options, choose source mode. And you'll see it's now highlighted source mode. What source mode means is if I do a step into, it will find, if that program's not already locked into source view, an automatic lock will be attempted so that we can trace it. So I'm sitting here on a constructor, on an object, so I'm going to say step into. So at this point, because of source mode, it says, oh, we want tracing where that constructor lives. We'll go and lock it in and continue the trace. So as you can see, this is the constructor that we were calling. From here, and it stopped on there. Now I'm going to try this step out. Well, I'm going to go ahead and step through a couple times. And also, so it does different items on there. And then when we leave it, I said step through, that's probably a bad thing. I'm not still there. Okay. So I go back to AP4, where it goes to the next instructions. So source mode, if you have it on, anytime you step into, it will automatically find the source file for you. If you do not have source mode on, it will only trace files that you specifically have locked in. I'm going to click that to turn it off. Now we are in a malloc, for instance, here, and I'm going to do the machine instruction. So I turn on machine instructions now, and being C code, and say step through or step into, you'll find that it actually has multiple instructions that it's doing. The malloc, that's the second instruction, third instruction, fourth instruction, fifth. So there are 5 assembly instructions that inside this C source program to do the malloc. So that's machine instructions a lot more. It does a lot more in C than it does in assembly because of that feature. Step that on. I already showed this, but you know, hovering. Right now it's initialized. I say step through, and now if I do it, you see it has a value. Because it has a value, I can expand it. by hovering on there, and it has an item, 2 items, you know, so I can keep and look in values all there, or over here in the variables and do the same thing on that one. Okay. And we just all the same type of features. We can step. Just like with a regular tracing without source level, there's this run no trace. What that does is saves all your source for your tracing and runs that ECB to completion. You may have a case where you captured one ECB to set something up, but what you really want to trace is the created ECB or the next ECB. So you may do run no trace, so it saves all your entries, and you can go do the second entry. Just show if you can do additional test, step into, and there's do initial test. Source for you tracing of a C program that is not optimized at this point. This program we chose wasn't optimized. A lot of times, I'm going ahead and I'm doing random trace to finish that out. Optimized code though. So this exact same program, I'm going to delete it, go back to my project, and I have the same program coded as optimized instead of not optimized. Now just on my system, I pretty much had to reload it from my project. But what you will do a lot of times on your system is you click down here and say add SO to view. And you would then get a dialog and you type in the 4-character SO name, and it would come up on this list, and you would double click and that would lock it in. And that's how you would usually do production or programs that are already loaded to the system. So this happens to be an optimized C code, the exact same program we had before. You'll notice as we go through, you'll see some lines just don't have blue dots. The reason for that is even though I declared this double of these two fields multiplied together, I never used this variable. So the optimizer decided not to even do any code for this line of statement because it wasn't used. Same thing over here on this loop. This is a loop 1 to 5 to alter the value of value, but I never use value anywhere else in this function. So the optimizer optimized it out. I'm going to create the ECB in the same constructor for the thing. Now you will see in this example of this program, we don't have any variables. We do have a little bug that we're working on right now that some optimized C programs just do not show the variables like they should. The results you have, it really depends upon your C program and maybe what version of software you have, if you will see them or not. But you really should see these local variables just like before. It's just a bug that we currently have that we're working on. So if you see no variables, hopefully in the next release or a fix that you may get in the next few months, that will show those variables. Because of that, even hovering won't work because this value here and this show the same thing. But stepping is the same thing. I just step through, and you'll see the same type of stuff. You will see an optimized C code sometime it jumping around. Now, I don't know if I have a real good case of that. This is a pretty straightforward program. Looking through the code just to see if I see something that might be a little more complicated. Not really. I'll see if I execute that point. So I'll set a breakpoint down here, and I'll see if I can. All right, there's an example of it. I stopped here, and I said step. Oh, that's all one. And it went directly to this line. And then it went back. That's because the optimizer chose to take the instructions for this line, do one assembly instruction, then do assembly instruction for this line, and then come back and do more of this. The optimizer has that control and that features. So when you optimize code, you may see as you step through that it bounces around. And that's just because the way the compiler generated, if you go to the listing and actually look at the generated assembly code, you'll see literally that this is moved around where there's one assembly for this, one for this, then more assembly for this. And I'll step through and finally it gets to the next instruction, and then it does some more of this, and then it's kind of straightforward. So optimized code does jump around, and also, like I said, the little bug we had doesn't always occur. Here we're seeing the variables. So if we come up here and we, maybe it's not going to hover right off. I'm not sure why it's not hovering, but we can see that we have these local temp int there declared. There's the value, 5. So the optimized bug with the variables just kind of come and go. Sometimes it doesn't show and sometimes it does. Let's see if there's anything else. I think those are the main features of source view trace, being able to lock in the concept, and you lock in what you actually want, to be able to do source mode, and it will automatically fetch the next instruction. Now source mode, once you turn it on, I'm not positive, but I believe it stays on as long as you're connected to the system. But if you disconnect and connect back, I think it goes off. I'm not positive, but I think so. So if you're a person that wants to use source mode, you may want to double check that it's highlighted when you come back in and make sure it's still there. I think those are the most features. One, are there questions I can answer or show examples of?
If you have any questions, please click on the hand raise button so that you will be unmuted, or pin us through chat.
Even if there's any specific issues you're having with source view trace, I am the architect for a company, one of the architects. I might be able to explain or help or at least get the information.
Yeah. Hi everyone. So I want to know, can you put trace directly on a function defined in the component?
Can you source trace back? I didn't quite understand the question.
Suppose we have one function called do testing, okay?
Uh-huh.
And it is defined under some component XYZ, and that XYZ function component is having multiple functions, but I want to put trace directly on do testing function. So can we put trace on that function directly?
Okay, I understand the question now. Okay, I'm going to go ahead and exit all ECBs. Our function trace, we're actually, I think in essence you're asking, is there such a thing as a function trace? You can trace specifically a function, right? Kind of?
Yeah.
Yeah, okay. We're actually looking at maybe some enhancements to this, but as of right now, from the list of files over here, if you take a source and you hit this expand, you'll see the different functions. And if you go in here, you can right-click and set function breakpoint. And what that means is if you hit any other breakpoints, you do your entry. When it enters this function, it will stop. So at that point, you can use the step next and continue from that point on. So this is a function breakpoint where you can literally say this is the function or functions that I want to stop on. So right now, that's our function trace breakpoint that we have. Does that answer your question?
Yeah, thank you.
Okay, thank you.
There's a question from Manu. Sorry, the question is, if I want to set trace on UIO, then how I can do that?
Okay, I think I've seen this one moving around. UIO1 probably. UIO1, I believe, is a system program, so it has to be compiled differently. And because it was a system program, there was not automatically source level tracing information. And what I mean by that is when we compile programs for ZTPFGI, and you may or may not have this little folder, but there's files generated called ZTPFGI VI files. But with UIO1 being a system program, it did not go through that process, only application programs did. The second thing is when we do a compile, our main configuration file is like either a make TPF config or a project _ make TPF config. It's some kind of config file. The one for system files are different than applications. So I think that's an outstanding question still. I actually got that question sent to me last week, and I did respond, I think, to Praveen or Naveen. I think it's Praveen. I don't know if either one of them is on the call. But, and I told him there's a system and we really haven't totally worked out the best way to make it where you can source level trace it without actually being like a system programmer and be able to compile it as a system type of thing. So I think that question is still really in the works and we haven't totally resolved it. But I just want to give you the background where it is and what's causing the issue.
Okay, Surabhi has pinged me again. Actually, I want to trace all program starts from UIO.
And you want to source level trace them? Or just macro trace?
Source level trace.
Source level trace. Today, because we use the lock-in concept, you really couldn't lock in all the UIO programs. The best way you would do that would be able to go into and set up your trace to be able to trace at the program at a macro level to begin with. And then once you stop, then you can turn on your source view with the lock-in thing. I'm trying to set here. This is sad, but I haven't done assembly traces for a long time. That sounds weird, but I haven't. Let me go ahead and create. Let's see. Source view. Let's see. I try and look for. All right. So in the select, you get to the trace options. You can say a program here, and you can say all UIO programs. So now that's what we're selectively tracing is UIO. When you do your entry, and if you captured if it's asynchronous, if it's normal, it will stop in the first UIO. At that point, you can attempt to lock in the program versus the little change I mentioned. If you lock in the first program, it stops on, and then you turn on the continue to automatically fetch the next program. It will go through and do one at the other. But the macro trace does do it for all UIOs. If you're not talking about source level, it will trace and it'll show you the macro stops, and you can go to instruction trace if you want. But to be able to do source view, you would have to lock it in and turn on the, sorry, I don't remember the option name, but the continue of the source. The source mode, you'd have to turn that on at that point to go from one to the next.
Okay, Surabhi is fine with your answer, Jeff.
Okay, thank you. All right, thank you.
It looks there's no questions.
Okay.
Thank you, Jeff. Thank you, everyone.
Thanks, everyone.